Okay, the first question says, if a car starts from rest and accelerates to a uniform speed of 200 km/h in 20 minutes, calculate its acceleration. Alright, the first thing to do is to say the velocity there is 200 km/h. So taking it to meter simply means we'll times this with 1000. So that we get 200,000 divided by 1 hour is equals to 3,600 seconds. So if you do this, you have 200,000 over 3,600, which will give you 5.56 meters per second. Alright, they said it happened in 20 minutes. So a minute to seconds is times 60. So I'll simply do t equals to 20 minutes, which is equals to 20 times 60 seconds, which is equals to 1200 seconds. So I'm still in question 1. So that means that to find the acceleration, like they said we should find the acceleration. To find the acceleration is equals to v over t, and we have v now to be 55.56, and we have time to be 1200 seconds. So this will give us this will give us 0.05 meter per second square. Yes, I should be correct. Alright, let's move to question 2. So question 2 says a body drags a bag of rice along a smooth horizontal floor with a force of 2 Newton applied at an angle 60 degrees to the floor. The work done after a distance is 3 meters. A distance of 3 meters is dash. So number 2. So we need to first of all ask ourselves, work done is equals to force times displacement. So when work is done at an angle to the horizontal, we know that S component is always cos theta. So that means force is being applied at an angle of cos theta. So work will now become F cos theta times displacement. W equals to 2 cos 60 times 3. W equals to 2 times 0.5 times 3 equals to 3 joules. 3 joules. That's my answer. Alright, number 3. I said if two forces of magnitude 2 Newton and 3 Newton. Okay, let's do it this way. Number 3. Two forces of magnitude 2 Newton and 3 Newton. Anytime you see this kind of question, know that x axis comes first. So I'll have 2 Newton, and it's happening at an angle. They are making an angle of 60 degrees. So I'll be 3 Newton. 2 Newton and 3 at the points are inclined at an angle of 60 degrees to each other. Find the magnitude of the resultant force. So you can see it. So this will now be the same thing as applying our laws. So that's this. What I have here is the same thing with what I have here. So triangular law, then parallelogram law, extending this. Whenever it is greater than or less than 90, I use parallelogram law. So I will now use the diagonal, and for me to use cosine rule, I always need to make the angle, to find the angle here, so that it will be opposite the resultant. So how to do that is to say angle on a straight line, then corresponding angle. So angle on a straight line is 180. 180 minus 60 is 120 degrees. So what I'm using is 120 degrees. So that means I can pull this out to mean the same thing as saying So now using cosine rule, I have r square equals to f1 square plus f2 square minus 2f1 f2 cos theta. R square equals to 2 square plus 3 square minus 2 into 2 times 3 cos 120 degrees. So this is now the same thing as saying r square equals to 4 plus 9 minus 2 into 6 times minus 0.5. Square equals to 4 plus 9, then plus. So this is 12 times half, so plus 6. So r square, taking the square root of both sides, so r is equals to 4.36 Newton. So that is my r. Another method to do this, we can use another method whenever I'm giving this type of question. Another method to do this, let's check it out, is I can say the minute I'm giving this, they gave me x, they gave me y, so I'll bring out all the forces given to me. They gave me 2 Newton, they gave me 3 Newton. So notice that the 2 Newton is happening at x, so I'll say 2. It's not happening at y, so I'll write y to be 0. Yes. So while for the 3 Newton, that is what I'm trying to use now is the method of see what I'm trying to do. $60 degrees, 2 Newton for x, and then means there's 3 Newton here. Y axis. So I'm trying to use horizontal component and vertical component. So you see, if you try to put this y to this side, you are going away, this 3 Newton away from the angle. Away from the angle, you use sine. Towards the angle, you use cos. So that's what I'm going to do. So trying to put this now to y-axis. Go and check my video on resolution and resultant vectors. To put this, you now have 3 on the x-axis, 3 cos 60. Why is trying to pull it this way towards the angle, you are closing this angle towards the angle, you use cos. Away from the angle, you use sine. So 3 sine 60. I see it. So when you do it very well, everything here, 3 cos 60 is going to give you 1.5. 3 sine 60 is going to give you 2.5981. So by the time you sum it up, you get 3.5 this side, and then you get 2.6 this side. So now you take it and use it and do Pythagoras, so that you don't do this side, triangular method, 2.6, 3.5. R square equals to 3.5 square minus 2.6 square. R square equals to 12.25 plus 6.76. Okay, R square is going to give you 19.01. So R, taking the square root of both sides, 2.01. So R is equals to 4.36 Newton. So you see, you are correct. So once you use, whenever you're given this kind of question, If you use cosine rule or use your solution of vectors, you will get the same answer for your resultant. That's how to know if you are correct. So remember, this is the question. If two forces 1 minute with 2 Newton and 3 Newton acting at 0 are inclined at an angle of 60 degrees to each other, find the magnitude of the resultant force. Alright, let's move to number 4. Number 4 says a block of mass 42 kg is lifted 6 meters in 20 seconds at uniform velocity. What is the average power required? Take G equals to 10 meters per second. Alright. So let's go to number 4. Number 4. So what we'll do is block of mass 42 kg is lifted. They carry it up 6 meters. The minute you lift something, G acceleration is no longer present. What you now have is acceleration due to gravity, and at uniform velocity acceleration is 0, and it has no business with acceleration due to gravity. Yes, so we'll remember they say we should find average power required. Remember that power is equals to force times distance, that is work done. Power is the rate of work done. So, and that is the sentence as in Fs over time, and this is the sentence as this. And what I have here, you can see very well that from the question they gave me displacement. That's displacement to be 6 meters in 20 seconds. So I'll simply do 6 over 20. Force itself is the sentence as saying mg, in this case not ma. So I have 42 times 10, which is the sentence as saying 420 times. Now 6 over 20 is the sentence saying 0.3. So the power is equals to 126 watts. So that's the power. Alright, so let's move to number 5. Number 5, okay. Let's define it from here. So we already defined it here. We already wrote it down. Say that potential energy. Okay, see what number 5 said. Number 5 said define potential energy and state its SI units and state its SI units of measurement. Okay. Potential energy is the energy possessed by a body due to its position, properties, and forces acting on it. It is also known as stored energy. We have potential energy due to gravity, which is potential energy equals to mg h, force times vertical distance. Then we also have potential energy due to elasticity. Potential energy equals to half kx squared, where k is elastic constant, x is displacement from rest position. The SI unit of newtons. Okay, number 6. So what is the unit of potential energy? The unit of potential energy is joules. You need to know that the unit of potential energy is joules. P energy is equals to joules. Joules is the SI unit. SI unit. Joules. Now the number 6 question. Number 6 question. The unit of Newton's gravitational constant is dash. So the answer, unit of Newton's gravitational constant is Newton meter squared per kg, because we know that Newton stated that force, should I say that force of gravity is given by a gravitational constant then times mass of the body and mass of the earth all over distance square, that is radius square. So by the time you make G subject of the formula, you see that you have this, and when you take it to this, you see that this is force Newton meter for radius square all over mass down here. This is mass, so mass square, which is kilogram square. That gives us the answer. Alright, now let's move to number 7. Number 7. A body is being pulled by the action of two forces, 6 Newton north and 8 Newton northwest. If the ropes make angle 50 degrees with each other, calculate the resultant force on the body and the direction it will tend to move. Let's try to dissect this question. The body, first of all, there's a body 6 Newton knots. Then the body is being put by the action of two forces. One, the force is acting 6 Newton, and there's another force pulling it. See, if you know the coordinates, I always tell my students, first draw the coordinates. So this is east, this is west, this is south. So they are pulling this other one north of west, and it's 8 Newton. So if that is the case, then I say that if the ropes make angle 50 degrees with each other, so making angle 50 degrees is more like as they are pulling the body, there's an angle here being made 50 degrees. Alright, so once we know this is a coplanar force question, and you can use resolution of vector or sine rule. So I'm going to be using the two methods. So for method 1, which is cosine method, I will simply say pull out everything I have here. So you see that what you have, 50 degrees is less than 90. That's why I'm using cosine rule. If it's up to 90, we use Pythagoras. So this is 6 Newton. This is 8 Newton. There's an angle here which is 50 degrees. Then this line here has another equivalent. When you place your ruler and draw the heights, it should give you something this way. So you're trying to use parallelogram. Remember that this is everything here is 6 Newton. Everything here is 8 Newton. There's also 8 Newton here. Somebody will say, why am I putting it here? Yes, all the forces acting here is in this direction. It's going this direction, and this is the force, 8 Newton. So further, we'll put it here, the same thing. So 6 Newton is here. That is this way and this way. Alright, so with that, we can draw a diagonal line so that we get this. Now that we get this using the diagonal line, we can now say, okay, judging this now, you see that this gives us that there's watch what I have here. This is angles on a straight line. Angles on a straight line. So I can say, yes, angles on a straight line. So I can say this is 50. What will remain here will be 130. 130 plus 50 gives you 180. Corresponding angle. This is corresponding to this. Because even if I project this, watch, I can form something here again, and something here again, and something here again, and it goes on and on. So that is why I say that here is 130 degrees. So as I've done it now, see how I placed it. The problem with some of you is that you like everything to be facing you the way you like it. Okay now, so I'll pull out this thing that I have now in a way. Now notice that what I have here, since I said this side is the same thing with this side, what I have here is the same thing with this side, 130 degrees. So I can pull out this thing the way you like it, because some of you are already catching headache. It's a triangle, it's because I'm using freehand. 130 degrees, 6 Newton, 8 Newton. So the resultant is here. Do you remember the rule of parallelogram? The diagonal gives you the resultant. So I will always find this angle. Very important. That's why I found it. Because whenever I want to do cosine rule, it's best to always use the angle facing the resultant. So which is 130 in this case. So cosine rule, r square equals to f1 square plus f2 square minus 2 f1 f2. So I have r square equals to 8 square plus 6 square minus 2 into 8 times 6 cos 130 degrees. R square equals to 64 plus 36 minus 2 into 48 cos 130 degrees. R square equals to 64 plus 36 minus. Okay. So 64 minus 36. Then if you times this, it becomes 96. Then minus cos 130 is 0.6428. Yes. Yes. So r square is equals to 64 plus 36 plus, because minus minus, when you times these two, now have plus 61.7088. So r square equals to, if you sum up, you have 161.7088. So take the square root of both sides, this will get us. So r will be equals to 12.7165. So r is approximately 13 Newton. Alright, method 2. Another method to do this is to simply say, as I have this now here, I'll say this is angle 50, Shebi. I'll say this is angle 50. From here to here is 90. 90 plus 50. 90 plus 50 is equals to 140. Now, everything here from this point, from here, this is second quadrant. It enters second quadrant. From here to here is 180. So I say that means everything here is 140. So getting here is 180. 180 minus 140. Equals to 40 degrees. Alright. Okay. Yes. So see, I've done something like that here. Let's see. Yes. So that is it's 90. That is from here. So this was 90 plus 50, 140. So angles on a straight line, 180 minus 140 is 40. I like to use this angle here because it gives me exactly the same thing. So you can see that if I come here now, applying the second method, see that it still gives me 13 Newton. Somebody will first ask me, how did I do it? I will say, since here is 40 degrees, if I try to push this towards the angle, is going towards x-axis, so it becomes 8 cos 40, which is what is here, and away from the angle it becomes 8 sin 40. Then when we come to the north side, this happened only on the y-axis, so it's only for y6. It didn't happen on the x-axis, so 0. When you do the mathematics, you get this. Then for the direction, you use tan theta equals to y over x. Then do the tan inverse, you get this. Alright, so back to our class. Then for the direction, see tan theta, do this. Then put y and x, y against s, yes, y divided by x. So by the time you finish, you get theta. So remember that it's in the first quadrant. So to get the direction, you go and minus whatever you have from 90. You have 58 degrees. That's your answer. So for number 8, let's look at the question to number 8. Where it says, given that a equals to 3i plus 2j plus k and b equals to 4i plus 3j minus 2k, calculate a cross b. So I already wrote this out, solved it already. So I said this means A magnitude and this means B magnitude. So to get magnitude, this is how you get magnitude. But remember, in this question, it's not magnitude they asked us to find. So I just did it so I use it to teach you. So B magnitude, this is how you find magnitude, B magnitude. But see what they asked us to find, the cross product. So we use determinant matrix I. Everything about I, you put it out here. Remember, everything about I is 3I plus 2J plus K. So everything about I is 3 and on the B is 4. So then everything about J, 2 and 3, everything about I. So when we want to do for I, using determinants, when we want to do for I, we tend to just like cancel out I. So it's more like, see, it's more like when I want to do I know that the value of I is 3 and 4. I will not use it. I'll just say, because I know that I have I, J, K. Whenever I want to cross, I take I and I is crossing. If I cross J, it will give me K. And if J cross K, it will give me I. So that means that J and K crossing. J and K crossing gives me I. So I'll cross J and K. So I'll use the values of J and K to find I. The same thing with J. So when I want to find J, I will do K cross I. If K cross I, the next thing it's getting is J. So that means K cross I is giving me J. So I use the value of I and K. Yes. So see what I did at the end of the day. I just said, since under I have 3 and 4. To find I just go to J. J is 2, 3. And K is 1 and minus 2. Then I now wrote I. Then to do J, so I now put minus always. Then to do J, I'll come here. To do J, everything about J is 2 and 3. I will not use it. I just go to I. I is 3, 4. Then K is 1 and minus 2. And that is what I will use. Then I put plus. Always remember minus before plus when you're doing determinants. Then to do K, I just come and write it out. Then this is everything under K. I will not use it. I'll just use I and J when I'm looking for K. So because you cannot cross K with K. K cross K is 0. It's not possible for K to cross K. So that's why I'm not using it. So 3, 4, that is for I. Then 2 and 3, the values under G. So then when I now want to multiply this is what you're seeing. I'll do left, right. That is why I have 2 times minus 2. Then 3 times minus 1. 3 times 1. So I use minus to separate it. That is from. Then come here for J. I do 3 lefts, which is why you see this 3 times 2 minus 2. Then right. That is why you see 1 times 4. Then for K, I do left 3 times 3. That is why you see 3 times 3 here. Then right 2 times 4. That is why you see this. Thank you. So by the time you multiply out, now 2 times 2 is minus 4. Then the minus 3 times 1 is 3. Then yes, 3 times 2 is minus 6. 1 times 4 is 4. Then the minus sign plus 3 times 3 is 9. 2 times 4 is 8 plus. So by the time you add up and subtract, you get 7I plus 10J plus I 1K, which is the same thing as saying minus 7I plus 10J plus K. So this becomes your cross product. This becomes your cross product. Now for dot product. For dot product, which is number 9, they told us if A equals to 2I plus 5J minus 3K and B equals to 3I minus J plus 2K, calculate A dot P. So we've already done it, and we know that dot product I dot I is 1, J dot J is 1, k dot k is 1. So what we just did is everything that is under I is the same thing as saying I means x-axis, j means y-axis, k means z-axis. So everything under I, bring it together, dot it. 2 dots 3 is 6. I dot I 1. 5 dot minus 1 minus 5. J dot J 1. So when you finish it, you get minus 5. That is how we did it. So we still gave an equation. You need to know this equation. This equation is used when you want to find the angle between the dot products. So we move to number 10 question. So number 10 question, this is it. They said a ball is projected horizontally. A ball is projected horizontally from a height 20 meters above the ground with an initial velocity of 34 meters per second at an angle of 50 degrees from the horizontal. Calculate the horizontal distance moved by the ball before hitting the ground. That is, they are asking us to calculate range. So to do this, all we just need to do is to say, let's draft it. So they said, from the question, they said a ball is projected horizontally from a height at an angle which is 50 degrees with initial velocity. You see it? So I wrote here, this is a case 3 projectile where a projectile is launched from height above the ground at an angle and it hits the ground level after some time. We find heights. That's the first thing we find, height. And you notice that to find height in this case, this type of motion is simply, notice that everything up here looks like your normal motion, your normal projectile, which is when a body is launched from the ground to ground level. So everything here. And how to find maximum height in such cases, use square sine square theta over 2g. So in this case, this particular case, how to find the maximum height for this type of projectile is simply to use square sine square theta over 2g plus the given height. So that is what we did here. We did u square, which is 34 square, sine 50, that square, all over 2g, which is 2 times 10, plus the given height, which is 20. Which is 20. Yes. So by the time you do all the maths, we get 53.92 meter for the height. Now to find the time. Why are we finding height and finding time? Reason being that we know that to find range, which they asked us to find in this question, always require ut, and we can't get t until we find this height. So that's why we first found the height. So secondly, we find the total time of flight for such a case of projectile. Now notice, if this is a b c, so to find time here will be, so the time of this projectile motion will be time from a to b, then plus time from b to c. That is time for it to move and reach maximum height. And we know that time to reach maximum height is u sine theta over g, plus time to move from b to c, that is to move from maximum height to c. And time from maximum height to ground is given by time to move from maximum height to ground level is given by this equation. And how do we get the equation? By using this, because we remember that when something is coming down, the initial velocity becomes 0. So times t is going to be 0, then plus the displacement changes to h when it's talking about height. So when you do this well, you get t equals to root 2h over g. And remember that the height here is 53.92 because it covered the whole height from this point to this, so you cover the total height. So when you put it together, this is the formula for time of flight in this case, in this type of projectile question. So anytime you ask question from under projectile that involves going from a height and then coming down, this is how you find the total time of flight. So we solved further using the u sine theta over g, which is 34 initial velocity sine 50 over 10 plus 2h over g, which is 2 times 53.92. So by the time we did everything combined plus, we got the time to be 5.9 seconds, which is 6 seconds. So remember that range, horizontal distance, is ut, but the u here, whenever it is happening at an angle, will be given by a horizontal component, which is u cos theta times the total time. So we now did 34 cos the angle given 50 times the total time we got, which is 5.9. so when you do it well, multiply, you get 129 meter. Thank you for staying with us. Subscribe. Thank you. Academic Daddy's channel, subscribe. Convert density of 0.0045 kilogram per centimeter cube to the SI unit. And we know that density is equals to mass over volume. Ihe juru eju ka ọ na ojuru eju. So mass of something, or the amount of something contained in a thing. So kilogram over meter cube is the SI unit. So what we just need to do is to ask ourselves, 1 meter equals to 100 centimeter. 1 meter cube is the same thing as saying 1 meter. So this is the same thing as saying 100 centimeter cube. So 100, 2, 4, 6 zeros. So this is going to be the same thing as saying meter cube. So 1 meter cube equals to 1, 2, 3, 4, 5, 6, 7. Very important. So whenever I'm asked to convert something, what I just need to do is, let's say for example they tell me convert 2 kg over cm cube to kg meter cube. What I just need to do is to say this is what they asked me to convert. Bring it at 2 kg over cm cube. Now kg, no need converting kg. So I'll now come and say times. I'll now bring a converting ratio, and I'll place whatever I'm bringing. I'll bring cm and meter, but I'll place cm in such a position that cm will cancel cm. So I'll put cm cube up here, put meter cube down here. Then I ask myself, how many meter cube makes centimeter cube? 1 meter cube make 100 or 1 million centimeter. 2, 4, 6. So once I know this, what it simply means is that this will cancel this. You see that I'm left with 2 million kilogram per meter cube. Very simple. So the same approach is what I will use for this question. So I will say 0. I'll say 0.0045 kg all over cm cube. You know that this thing means per, which is the same thing as when it comes down here. Now to convert to kg meter cube is times. I'll say put cm cube up here, so that cm cube will cancel cm cube all over meter cube. So I'll now ask myself, how many meter cube makes centimeter cube? 1 million. 1 meter cube makes 1 million centimeter cube. This will cancel this. So by the time you times this, you are having around with this times, so you're having around 4,500 kilogram per meter cube. Very simple. Now 10 gram per centimeter cube, the SI units, and this density we are dealing with. So 10 gram per centimeter cube will be equals to 10 gram all over cm cube equals to, I'll ask myself, this is gram and the unit of density is kilogram. So I'll ask myself, multiply what I have here first of all convert to gram before centimeter cube. So whichever way you want to do it, so I'll ask myself, how many gram make 1 kilo, or how many kilogram make 1 gram? 1 kilogram is equals to 1000 gram, which means that what it means is that 1000 gram makes 1 kilogram. And also I can also write it this way: 1 kilogram makes 1000 gram. So it depends how I'm writing this, how I'm placing this depends on what I'm given. So notice that this is 10 gram centimeter cube. So since it's in gram that I am in, so I'll simply put gram in a place where gram can cancel gram. So I'll now remember 1000 gram equals to 1 kilogram. So that this will cancel this will cancel this, which means that I'm left with 1 divided by 100, around 0.01, Shebi? Then remember that I have centimeter cube here, so convert it to meter. So I'll ask myself, place meter centimeter cube where it will be able to cancel centimeter cube all over meter cube. So 1 meter cube gives me 1 million. Yes, 1 million centimeter cube. Yes. So very important. What matters is once they tell you to convert anything, your problem is to know what a meter is to in centimeter and what gram is to kilogram. Then now whatever you are given, you'll be placing what you are bringing in a position where what you are giving will cancel what you are bringing, so that you have what you are looking for. So this will cancel this. So 100 cancel 100. So I'm left with, if you multiply now, I'm left with 10,000 kilogram per meter cube. Very simple. So that is how you convert from meter to centimeter cube and from gram to kilogram. So next question said, show that 1 watt equals to 10 raised to power 7 egg. Okay, 1 watt equals to 10 raised to power 7 egg per second. Okay, what you first of all do is to remember, we need to first of all tell ourselves 1 watt is the same thing as saying power is equals to force times displacement all over time. We remember, yes, remember that power is equals to work done, the rate of work done. So, and you need to know that force on its own is equals to Newton, and displacement on its own is equals to meter, and 1 Newton is equals to 10 raised to power 5 dyne, and 1 meter is equals to 10 raised to power 2 centimeter. And you need to know that the product of dyne and centimeter equals egg. Are you seeing it? So what it means now is that I'll bring, this is the sentence saying, replace with Newton with 10 raised to power 5 dyne, since 1 Newton equals to 10 raised to power 5 dyne, times 1 meter is displacement is in meter, and 1 meter is equals to 10 raised to power 2 centimeter, and dyne times centimeter gives you egg. So that means that I have 10 raised to power 5 times 10 raised to power 2, and this times this gives you ERG. That is for this one. And remember that everything is being divided by time, and time is in seconds. And in this it says that when the powers are the same, you can add it. When the bases are the same, you can add the power. So this becomes 10 raised to power 5 plus 2 egg over second. So this becomes 10 raised to power 7 egg per second. And this is the sentence saying 10 raised to power 7 egg per second. So proved, we've shown it. Very important. Okay, they said it is necessary to specify the temperature of which a standard meter is made. Why? Reason is that temperature determines the size and shape of things. For example, if you heat something, or if cold, there is so much cold in some things, the thing will tend to fold or drop in size. And if you heat something, it might extend. Yes, so temperature determines a lot. They say, do you consider temperature a fundamental quantity? Yes. The reason is that all fundamental quantities are scalar quantities. So this is what you write: all fundamental quantities and scalar quantities. And you cannot tell somebody, I am feeling hot in northeast direction, and you cannot tell somebody, I am feeling cold in northwest direction, or in east direction, or in north direction. It's not possible. So temperature is a fundamental quantity. All right, they say list the unit and dimension of velocity. Okay, let's do it fast. Okay, velocity first. You know that velocity is equals to displacement over time, and this is meter per second, and this is something that's saying length over time. So which means that the unit of this is meter per second, or yes, for units, this is the unit, and length per time, this is the dimension. Okay. The next one, force. You know that force, from the equation of Newton's second law, it says that the force applied is directly proportional to the rate of change of momentum. And you know that everything here is a, while what we have up here is momentum. So it's from this equation we now get ma, F equals to ma. Yes, you can put equals, first of all, F equals to kmv over t. And this is the dimensionless constant, which is 1. So from this we have F equals to, mass is kilogram, acceleration is velocity over time, which is meter per second over seconds. So F is equals to kilogram meter per second. Then anything standing on this one, this is the sentence, this thing here is the sentence as saying 1 over s. So this is 2 power minus 1. And you add it up, you have kilogram meter per second minus 1. So this becomes the units for force. So the dimension for force is simply m, l, for this one, t raised to power minus 2. So this is the dimension. Alright, I'm trying to be very fast. We've done this in class. Work. So for work is force times displacement, not distance but displacement. That's why work is a scalar quantity, vector times vector. So I know that this one is kilogram meter per second square, then times s. So you see that this is going to be kilogram meter per second, then it's 1. So this is the units of work. You know that yes, work is given in joules, and the reason why work is given in joules is because notice this is Newton, this is meter, shebi. But we have another quantity that is also in this unit, which is torque. Torque is Fr, and this one is distance around the rotating body. So torque is given by 4 Newton meter to differentiate it from work. So work is in joules. We need to know this, the center within each. So the dimension of this is going to be m, LT. So NH, NH is the same thing. E, tension. Whenever you're talking about a rope or the force on a rope, or naturally we know that force applied on a body, that there's always resistance to it, which we call friction. But opposing force, like when you try to push something, that opposing force that it's the object itself gives you is what you call tension. So tension equals to force, opposing force. So it's the same thing as Newton. Remember, force is Newton. All those things you are seeing us doing, yes, it's the same thing as Newton, because Newton is like a unit that we give force, named after Isaac Newton for his numerous work on force. So acceleration equals to velocity over time, and we know that velocity is meter per second over second. So this becomes meter per second minus 1 second square, which is the same thing as LT minus 2. That's G. Linear momentum. Linear is line, straight line momentum, because we still have angular momentum. So one dimension momentum, like when it's moving horizontally. So this is mass, product of mass and velocity. And we know that mass is kilogram, velocity is meter per second. We'll still do momentum, so I don't want to start talking much about it now. So this is going to be kilogram mass LT minus 1. H, torque. Torque is the product of force and displacement. But distance, or you say distance, sorry, not displacement, distance around the rotating body. So torque is a vector quantity, because you can see that this is vector times scalar, and I told you vector times scalar is vector. Yes. So while work itself is force times displacement, which is vector times vector, which is scalar. So you need to know this. So it's the same thing. This one is Newton meter. It's given in Newton meter. So it's still the same thing. You can also write the same thing you have here, which is kilogram meter yes per second, which is MLT in dimension. Alright, let's move to the next one. Angle is given in radians, and this is the same thing as arc length over radius, and altogether this is meter over meter, which is equals to 1. So we say that angle is dimensionless. Angle is a dimensionless quantity, but the angle is given by its unit is radians. Density is mass over volume, which is kilogram per meter cube, which is ml raised to power minus 3. Density G. So this is density. Pressure is Pascal. K. Pressure is force over area. Then action. Action is product of work done and time. So product of work done and time is action. So this is going to be, you know that this work done is kilogram meter per second times second. So this is going to be kilogram meter per plus 1. So it's simply kilogram meter minus 1 plus 1 is 0. And anything raised to power 0 is just, so kilogram meter. Yes, because minus 1 plus 1 means it is going to have 0 power. zero power, and this is going to be the something as in kilogram meter. So then pressure, force over area, kilogram meter per second square all over meter square. This cancel this, so that you have kilogram per meter per second square for area, or you call it pascals. Power is equals to work done over time, which is the same thing as saying kilogram work done kilogram meter per second all over per second. So this is something as saying kilogram meter minus 1, so it's equals to kilogram meter per second square. Kilogram per meter per second square. Alright, so 5 square. Notice this is the question given to us, a practical question. They say we should complete the table above. It's not hard. 5 square 25, 10 square 100, 20 square 400, 30 square 900, 40 square 1600, 50 square 2500. Now we check our graph. If you check your graph, they say we should plot graph of v against v square, which means that when they say v against v square, it means that your vertical axis will be v, your horizontal axis will be v square, because they said v against v square. Now you need to check again. If you count your normal graph, the standard red graph, you get that the number of points here will be 10 points, and the number of points this side will be 12 points. So what I want you to do on this point now, the standard method of doing this is to say the highest point here is 2500. 2500 divided by 10 points, because we are plotting this on the horizontal axis. 2500 divided by 10 is 250. So each point on your graph should be 250. It's 250, 500, 750, 1000, yes, 1000, 1250, and so on. While on this side, if we divide by 12, it will give us 4 point something thereabouts, but I want you to use each 2 centimeter 5 centimeters, so 5, 10, 15, 20 there and thereabouts to plot. So when you finish plotting your graph, you should have points of intersections. So you should have points of intersection. If the normal standard is that your point of intersection, which we'll call the line that will cross here, is called the line of best fit. This line I'm drawing now, the line that crosses your points of intersection, is called line of best fit. So you should, by right, you should touch 3 points, and if it doesn't touch, because maybe this one is not having so many points, it should be in the points outside should be alternating, so that if you have something here, the next one should come here. Next one. That's how to know if your graph is correct. Now I'm trying to quickly show you what is slope. To determine slope, I will make out time to use graph and plot this. So to determine slope at any point on this, but the bigger your triangle that you draw, the more accurate. For anybody looking at it, would dictate that it's more accurate when the triangle is bigger. So at any point here, I can draw something here, a straight line, draw a horizontal line. All I will do now is to trace that horizontal vertical line down, trace it down, trace here, trace here, trace here. So whatever I get here becomes my v2, or you call it, since it's vertical axis, let's use y2, y1. Let's use whatever I get here becomes x2, whatever I have here becomes x1. So slope, the slope is simply given by vertical whatever value you have on the vertical axis divided by the horizontal axis. So which is essentially saying whatever point I have there is y2 minus y1 all over x2 minus x1. Whatever you get becomes your slope. And the formula, the unit your slope will carry simply by doing, since this one is v and v square. So you remember that velocity is meter per second. Why this one is meter per second all squared. So by the time you cancel out, you get your unit for the slope. Now the intercept. What is intercept? You need to know that intercept is simply the point where your line of best fits touches your vertical line. You see this line of best fits? The point where it touches this vertical line, this is the vertical line. The point where it touches it, whatever value you have here, let's say is 2, becomes your intercept. So C equals to 2. And notice that it's on, this one is given by V, so it's going to be 2 meters per second as your intercept. So you need to know that. So intercept is the line where is the point where line of best fit meets the vertical axis or the vertical line. So and you know that there's an equation. So just like when I'll be doing the graph class, like I said, there's an equation of straight line y equals to mx plus c. So this is the intercept, y-intercept. So that we are talking about the point where line of best fit meets. So it's not every time they give you start using this equation to solve. There's a time where you use this equation to solve. Let's say a situation where your intercept is such that, for example, you have a graph. Let's say you have a graph like this, and you come and let's say this is the end of your book. You come and have a point of this nature. Notice that if you start projecting this, they will be going up to a point maybe where they will meet. So a situation where it's not hard to find this intercept, that is where you employ this formula. You need to know that this one stands for slope. This one stands for x points, the points of x or x itself. This one stands for y. Just note it, we'll still use it to solve so you understand better. Error in slope. To calculate error in slope, we simply do SG equals to 4W all over NR, where W is vertical scatter. All those points that your line of best fit couldn't touch is what we call W, vertical scatter. N is number of observation. Like in this graph now, we have 6 observations, serial number 106. So number of observations. YR is the horizontal distance, or you say notice that from what we did here, what is it? From what we did here, see from what we did here, v squared, this is the value that is going to the horizontal side. So what is the highest value here? The highest value is 25. What is the lowest value? The lowest value is 20. The highest value is 2005, the lowest value is 25. So the R will simply be 25 minus 25, and that should be giving me 2475. Should be? Yes. So that is my range, my R in this case. So you need to know that the highest horizontal value minus the lowest horizontal value. Alright, so please, we will still be plotting this graph. We'll be taking time to plot this graph. For now, what we are just doing is explaining everything. So we'll be taking time to plot and upload the graph.